Company A wants to meet demand of 1000 ton per year of chemicals to supply customers. But Company A unable to meet the 100% demand and able to supply only 700 ton per year. Then customer decided to source another company called B to supply shortage quantity of balance 300 ton per year. Then from next year, customer decided to allocate 100% business to company B. It means no business to company A. So company A got huge money loss due to this problem. The reason is the company A faced too many failures of critical equipments, which impacts major production loss, high repair cost, equipment life got reduced, and increased capital expenditure. Both companies having same type of process equipments, but company B maintained the best preventive maintenance practice to meet the required demand, whereas the company A having lack of preventive maintenance. And this creates a huge loss, unable to meet the customer's demand from company A. So the maintenance reliability engineers came into the role to fix this concern, to adopt the best preventive maintenance practice to recover the company from huge loss. And how the maintenance engineer can recover the company loss by adopting the best practices of preventive maintenance. Of course, the maintenance engineer is completely responsible for following the best practices to implement the preventive maintenance in an equipment. Development is maintenance. Yes, if he follows, he can save the company from major failures. So that is the reason the company got failed if they didn't follow a proper preventive maintenance methodology. Welcome to Refresh Engineers. Preventive maintenance is must. How to adopt the best practices? How the maintenance engineer going to adopt the best preventive maintenance methodology in any industries? In my previous video, I explained about the types of maintenance. There are two types of maintenance: preventive maintenance and corrective maintenance. If you want to watch my previous video, the title is Avoid 3 Risks by Preventive Maintenance. I provide the previous video link in the comment section. You can just go through the link and you can watch the videos. Now let us watch what are the types of preventive maintenance to be handled by the maintenance engineers to avoid the major failures. Keep on enjoying watching these videos. There are 3 types of preventive maintenance: time-based maintenance, risk-based maintenance, and condition-based maintenance. Time-based maintenance. You may have the clarification, why time-based maintenance? All preventive maintenance are time-based maintenance, scheduled maintenance. If it is no time-based maintenance, then it is called emergency maintenance. According to time-based maintenance concept, it treats failure only for aging components. Simply a small or accessible parts like belts, hoses and couplings means which never require to open or destack the equipments, and the parts can be replaced in defined interval of time. If an equipment behavior is going worse, even if we follow the time-based maintenance, immediately the maintenance engineer conduct a risk assessment on the failuring equipment. Then he develop a risk-based maintenance schedule. Yes, maybe he will increase the frequency of time-based inspection or time-based maintenance to improve the reliability and performance of the equipment.
In risk-based maintenance, if an equipment behavior permits for more maintenance or repair, the risk-based maintenance shall be implemented, and it follows the methodology of risk assessment. Yes, the maintenance engineer start doing the risk assessment on the failure equipments, and this is applicable for most of the static equipments. So static equipments like column vessels, exchangers, this risk-based inspection in RBI in short form, they used to call the maintenance engineers. They can perform the risk-based inspection, and they will recommend what to be done on interval basis. So this is applicable for static equipments as well as the safety critical equipments.
So the outside simple parts like hoses or pipeline or couplings or belt drive, we can easily do the maintenance. We can easily change the parts. We can check by physically by our own vision what is the condition of the parts. Many parts are running inside the equipments. How we can evaluate, how we can identify the condition. This only method is the condition monitoring. Yes, the physical evidence, to ensure the physical evidence of the behavior of the internal parts of the equipments is monitored by condition-based maintenance. So once we get to the data after doing the condition monitoring, we can do for next action, the maintenance action, the repair actions. So the advanced technology of condition monitoring is called the predictive maintenance. The predictive maintenance is nothing but the advanced technology of the condition monitoring, like by using the artificial intelligence, machine learning, and different types of sensors has been used to monitor the conditions of the equipments.
Early stages of failures of equipments with evidence which is not due to aging or related to aging of equipment components can be identified by using condition monitoring techniques. Mostly, this condition-based maintenance can be applicable for rotating equipments. And the main concept followed in the condition-based maintenance is PF curve. It's a graph to compare the condition, the equipment behavior versus the time. So the earliest possible prediction of equipment failure can be detected by using a vibration sensor or temperature sensors or artificial intelligence. And we used to collect the data by using the machine learning. We can predict the earliest failure of any equipments with evidence. So this is the modern technologies of condition-based maintenance. So here in this PF curve, the potential failure occurs at the point P. So from that instant, we need to plan for the action to avoid the complete functional failures. If you pass the time of functional failure F, then it is the emergency or corrective maintenance. So the maintenance reliability engineers can have a handheld control on the PF curve on each the critical equipments. So during this PF interval, they should recover from the major failures. They will decide when it can be sorted out, all the failures can be repaired before crossing the functional failure point. Development is preventive maintenance. So follow preventive maintenance to minimize production loss Follow preventive maintenance to reduce the maintenance cost. Follow preventive maintenance to extend equipment life. Follow preventive maintenance to reduce capital expenditures. So preventive maintenance is must. Thanks for watching the video. See you again in the next video.